All right, and now we have our video for 2.4. 2.4 is dealing with elimination using multiplication. So remember, we're still in our unit about solving systems of equations. Elimination is a way to do this algebraically. And by that I mean we're not using graphs. You shouldn't have to draw any graphs to find the solutions here. We're just using algebra and using our kind of problem solving methods and our orders of operations, stuff like that. We're working with the equations and changing them to figure things out without using any graphs. So for this one, for elimination using multiplication, it's going to be very similar to our elimination using the addition or subtraction stuff, only before you can add the two equations together, you have to multiply one or both of them by something to change it. And again, I'll show you what it looks like as we kind of work through here. So looking at our first example, we have to solve the system using elimination. Our two equations that we're looking at, our first one is 6x plus 5y equals negative 6. Our second one here is x minus 9y equals negative 1. And remember, you can kind of think of that second one as saying x plus negative 9y equals negative 1. If it helps you to think of things as adding a negative version, so it's like negative 9 is being multiplied by y, and not just 9 there. Okay, so those are our two equations, and we need to get at least one piece of that equal. When I say one piece, I mean one of our variables has to be opposite. So if we look at our x terms here, we have 6x and just x. So those ones are not opposite of each other right now. We would need the other one to be negative 6x to be opposite of 6x. Same thing if we look at our y's. We have 5y in this case, or a positive 5y. We would need a negative 5y to be opposite. But we have negative 9. Same thing with our x. We would need negative 6. We just have 1 as kind of our coefficient out in front of there. It's just 1x. But we can change this. Okay, we can take one of our equations or both and multiply them by something so that they will be the same. So in this case, I'm going to change mine. The top one, I'm just going to leave it the same. So there's no change. I just move it over, keep it exactly how it was before as 6x plus 5y equals negative 6. So there's no change with that one. This bottom one, though, again, I notice as I'm looking at my x's, I have positive 6x up here and just x in this one. I can easily make those opposites if I multiply the bottom one by negative 6. So each term is being multiplied by negative 6. Okay, so if I do this piece, the x times negative 6, that's going to become negative 6x. If I do this piece, remember it's like saying negative 9y, then it becomes positive 54y. Negative 9 times negative 6 is positive 54. So that becomes, we're adding 54y. And then our last piece here, negative 1 times negative 6 is going to become positive 6, or just 6. Okay, so the top one stayed the exact same. It's that bottom one that we changed by multiplying first. So now I have, again, two equations, both with the same variables. So I have 6x plus 5y equals negative 6 is my top one. My bottom one is now negative 6x plus 54y equals 6. Now I have them in a spot where, again, looking at these x values, they're opposite. I have a 6x and a negative 6x. So that'll make it much more easy to do elimination. Now when I combine these equations and add them together, 6x and negative 6x, 0x. So we got rid of our x term. 5y and 54y become positive 59y. And then negative 6 and positive 6 would add together to just be 0. So again, this piece is, it's like it's no longer there. We got rid of our x pieces, so we just have 59y equals 0. So to get y alone, I I divide each side by 59. Now 0 divided by anything, including 59, 0 divided by 59 would just be 0. So in this case, we found out y equals 0. That's going to be our y value of the solution to this system of equations. So again, like before, using elimination with addition, once you find out one of those pieces, one value, once you get y to just equal something, you simply plug it into one of the other equations. So I'm going to plug it into the first one, and it doesn't really matter. You can plug it into the bottom one too. I just happened to pick the first one. So instead of 6x plus 5y equals negative 6, I have to plug in 0 everywhere I see y. So 6x plus 5 times 0 equals negative 6. Now remember, this means I'm multiplying 5 times 0, which is going to be 0. So we've changed it now to 6x plus 0 equals negative 6. Okay, simplifying that more, I can kind of get rid of that 0. Adding 0 doesn't really change anything. So now it's 6x equals negative 6. So to get rid of that, I need to divide by 6 on both sides of my equation. When I do that, I get x equals negative 1. So in this case, we would say the solution to this system is negative 1, 0. This is going to be the point where both equations cross. Again, if we were to change this into a graph and graph our two lines, they would cross each other at the point negative 1, 0. So going on to example 2. Again, we're solving our system using elimination. If we look at our terms, if we look at our x terms here, negative 6 in front of x and 9 in front of x. So those don't match up. Same thing if we look at our y's. Positive 5y and positive 3y. Those don't necessarily match up. Neither of our variables here are opposites of each other. Okay, we need like negative 6x and positive 6x, or positive 5y and negative 5y. We don't have that in either of them. So in this case, we're going to have to multiply both equations by something so that they will, again, be opposites of each other. So what I'm actually going to be trying to get the same is my y values. I have a 5y here, and I have a 3y here. So I notice that 5 and 3, I can get them both to a 15. 5 times 3 is 15. Sorry, that should be a 1, 5. But one of them I need to be negative, and one of them I need to be positive. So to keep the top one positive, I multiply everything by positive 3. To get the bottom one to be negative, I have to multiply everything by negative 5. When I do that, the top one, again, everything is being multiplied by 3. Negative 6 times 3 becomes negative 18x. So we had this negative 6x times 3. Same thing. That positive 5y times 3 is going to be positive 15y. And lastly, if I take that 27, multiply it by 3, I'm going to get positive 81. Okay, so I multiplied each piece, my x, 5y, and 27, all multiplied by 3, and it changed it to this new equation. Okay, now I need to look at my bottom equation. I'm multiplying each piece by negative 5. So if I look at 9x and I'm multiplying it by negative 5, well, 9 times negative 5 is negative 45. So I have negative 45x. Similarly, I've got 3y. 3y times negative 5 is going to be negative 15y. And our last chunk here is negative 9 times negative 5. Negative times a negative is positive, so it becomes a positive 45. Now you might be asking, why didn't we change the x's to be equal? Well, we could have. We could have just as easily. You could have taken the 6 or negative 6x here and tried to get it the same as our 9x down here, in which case you would probably multiply these by 2 so that we'd get it to a 19x, and we multiply everything up here by 3. Again, that would get us to a negative 18x. That would have worked just as fine. We could have done it that way as well. In this case, we just happened to choose to get y's away. We're trying to kind of cancel out our y's. You can cancel out x's too, that's fine. We just happen to pick canceling out the y's in this case. Okay, now that we've changed our equations, changed both of them to something new, now is when we add them up, just like our normal elimination method. So negative 18x and a negative 45x actually becomes negative 63x. Positive 15y and negative 15y become 0y, and 81 plus 45 becomes 126. So when we add our two equations together, this is our new equation that we're looking at. Okay, and again, this means we don't really need our y value anymore. So it's just negative 63 times x equals 126. To get rid of that negative 63, we're dividing both sides by negative 63. I have to divide this side too by negative 63. Okay, this piece will just become x, because we got rid of that negative 63 out in front of it. 126 divided by negative 63. Positive divided by negative has to be negative. 126 divided by 63 is 2. So we figured out x has to be negative 2 in this case. Again, just like before, we take whatever value we've solved for, so in this case x, and we just plug it into one of our first equations. Again, doesn't matter which one you pick. You can plug it into either equation. You're just plugging in our x is negative 2 in wherever you see x. So I happen to pick the bottom equation here. I'm just plugging it in. So 9 times negative 2 plus 3y equals negative 9. Simplifying pieces out, 9 times negative 2 is going to come out to negative 18. Plus that 3y, well, we don't know what y is yet, so it stays as 3y equals negative 9. In this case, again, if we want to kind of get our y term all alone, we have to get all the other terms away, so we have to add 18 to both sides. Adding 18 gets rid of that piece, so we would now have y, or 3y equals 9. Negative 9 plus 18 is just going to be 9. Okay, again, if we want to get y alone, we're going to divide by 3. Do the same to the other side, divide by 3. And we would get y equals 3. So again, in this case, our solution for this one, the spot where both lines go through at the same time, where they'll intersect, is at the point negative 2, 3. All right, we've got another one, solving this system using elimination. Okay, again, if we look at our individual pieces, 5x and 2x do not match up. 8y and 6y do not match up. Okay, so we can't just cancel things out right away by adding them. We're going to have to multiply things. So in this case, last time I think I canceled out my y's. This time let's try canceling out the x's. So we have 5x and 2x. Well, 5 and 2, I can get 10 from that. That's kind of our least common multiple. It's the first number that they'll both go into. So if I want to get my 5x to being a positive 10, I'm going to have to multiply by 2. Because one of them needs to be positive and the other one needs to be negative. If I need to get my bottom one, that 2x, to being a negative 10, I'm going to have to multiply everything by negative 5. Okay, so we know each piece of our um, system here, each equation needs to be multiplied by something different. Okay, so if I do the top one being multiplied by 2, I'd say 5x times 2 is 10x. Then I take my 8y times 2, that becomes 16y. Take that negative 1 times 2, and that becomes negative 2. So we've changed the top equation to something completely new. Same thing if I look at my bottom equation, I'm multiplying each piece times negative 5. 2x times negative 5 is negative 10x. And right there, our x values, those are now the ones that are going to be opposite. We have a positive 10x and a negative 10x. So now they will kind of cancel each other out. We'll get rid of the x's in this case, or we will eliminate the x's. Okay, moving right along, we have this 6y being multiplied by negative 5. That's going to become negative 30y. 6 times 5 is 30. Positive times negative is negative, so negative 30y. And 8 times negative 5, again, it's going to be a negative 40. So we have our two different equations, one having a positive 10x, one having a negative 10x. So when we add our x's together, we get 0x. When we add our y values together, positive 16 and negative 30 becomes negative 14y. And we add just our constant terms, so the ones without a variable, negative 2 and negative 40 become negative 42. Like before, this is basically like saying we don't need that piece, or we don't have that. So negative 14y equals negative 42. Divide both sides by negative 14. Divide by negative 14. When I do that, dividing out the negative 14 from each side, I get y alone. Negative 42 divided by negative 14, well, a negative divided by negative is positive. 42 divided by 14 is 3. So y equals positive 3. Okay? Just like before, we take that y value, the one that we've solved for, 3, and we plug it into one of our equations. So I'm going to use the top one this time, 5x plus 8 times y, which is actually 8 times 3, because we know y is 3. So 5x plus 8 times 3 equals negative 1. Again, in this case, 8 times 3 we can simplify to being just 24. So 5x plus the constant term 24 equals negative 1. If we want to get our x term alone, we're going to have to subtract 24 from both sides. When we do that, that leaves just 5x equals negative 25. To get x all alone now, we're going to divide both sides by 5. So we get x alone equals negative 5. X is negative 5. Y is positive 3. So our solution, the spot where these two lines are going to cross each other, is at negative 5, 3. This is our one and only solution, the one and only point where both of these lines will cross.